Okay, so this is a review and preview to Chapter 4 in the Calculus 30 course. And what we're talking about here is interval notation. Right here, interval notation. Now, we've taken a look at notation before in the past called set notation. That's the old style. And if we had, for example, a domain equals x is greater than 2, what this means is that x can be any value that is not includes 2 but is greater than 2. So any of these values here on the number line greater than 2. Interval notation is just a different way to notate intervals of the number line. Okay, so there's two types of notation that we have to take a look at here. One is a square bracket. If you see a square bracket, that means the values include the value here. So this includes a. That's what the square bracket means. Okay, and of course this other square bracket, it also means it includes b. And so when we have a comma b enclosed in square brackets on both sides, it means this. It means that the x value, let's just call it x, is on this interval. The x value is between, so it's greater than and less than or equal to. It's greater than or equal to a, and it's less than or equal to b. So do you remember this set notation? Yeah? So it includes a and it includes b. So this comma, it's almost like this comma means all values in between. If we were to draw that, it would look like this. There's a. Because a is mentioned first, that means it's the smaller value. And here's b. And it would include a, so we'd use a solid dot there. And it would be all values in between and including b. Okay? So that's what this interval notation means. So I'll just clean that up just a little bit for you. And I got to put that comma back in there. Okay? Does everyone understand that so far? Just a bit? Okay. All right, the other type of notation here is the round bracket. Okay? So this means not including a. So this is also called an open bracket. Okay? And I'll put that down here. An open interval. This is an open interval because it does not include a and it does not include b, but it includes everything in between. So this would look like this: a less than x less than b with no equal sign. That's open. If this is open with these brackets, what do you suppose this notation would be called?
Closed.
Yes, very good. Closed. So this is a closed interval, which I didn't mention when we were there, but closed interval. Okay, open, closed. And the representation, of course, would look like this, with an open circle there on both a and b, and everything in between. Okay, are you getting the picture there? For open and closed? Okay. Now this one has a combination. Okay? What this one means right here, that's a closed bracket. This would be an open bracket. This closed bracket means that x does include a. But this open bracket means x does not include b. And the visual on the number line would look like this. Closed solid circle there, everything in between, and an open circle at B. Any questions about that? So here's another one too. If we mean x is less than or equal to b, okay, if that's the set notation here. And this set notation really should have the braces on it, okay. I didn't put that on there before, but really if we're talking about the set notation, they should have these special braces on, right? Now, where are we? Okay, so if we mean x is less than or equal to b, then the interval notation would be the lower limit is a negative infinity. And because negative infinity is not an actual value, it's just a concept. It's not an actual number. Okay? It's just a concept. That means it always has an open bracket. So with infinity, it always has an open bracket. Okay? If it includes b, we use the closed bracket. So on a number line, if I say, here's 5, there's that, and it goes on forever in that direction, in interval notation, how do I represent that? In interval notation. Well, I'm going to have 5 there, and it's going to go to what?
Positive infinity.
Yeah, positive infinity. If it's positive, you don't normally have to use the positive sign there even. But is this going to be an open bracket or a closed bracket around infinity? Yeah, open. It's always rounded. This one includes 5, so what kind of bracket do I have here? A square bracket, okay? And if this dot right here was open, then this bracket would be open as well. It would be rounded. Okay? Understand? Okay. So another little thing that we need to take a look at is sign analysis. So sign analysis is something that you've done before in math. You may or may not remember it, but it's going to come up, okay? So in Chapter 4, what we're dealing with is maximum or minimum values. They're called extreme values in the textbook. And we need to know, for example, on a function, we need to know if there is a maximum point like this. And I want to know where that x value is, and I want to know what that y value is. So this point right here in calculus is of great interest to us. So are these points that are zeros and the minimum points here. So those points are really important. So what kind of things do we need to be able to do in math to find those points? Well, if we're given a function like this, okay, there is a mathematical method to solving for where the graph is positive. So this is positive area above the x-axis, so it's positive y, where y values are positive. And these would be the negative values. Oh, I meant to change colors there. The negative values, these are negative. So the y values are negative below the x-axis. So a question that you might get is, here's your graph, y equals x plus 1 times x minus 2 times x minus 3. And where is y positive? Okay, that's a question. So for what values of x make this y, or this whole expression right here, make it positive? And if you wanted to just test some answers, you might be testing for a long time. Like for example, what if we say 5? Okay, if x is 5, what is y? Is it positive or negative? And you'd have to substitute 5 here and figure it out, right? So that's going to be 6 times 3 times 2. That's going to be 36. So it's positive there. Okay, great. But what about in other values of x? You don't want to test each value of x, right? Too long. So what we can do is we can analyze, that's what analysis means, we can analyze the function. And what we want to find is, we want to find where the roots are. That is, these things right here. Where does this graph touch the x-axis? And that will also help us to know which regions are above the axis and which regions are below. So I'm going to just erase this to give myself some room here, okay? So you can leave yours there, but all right. So what we're going to do is we're going to try and find out, first of all, where the zeros are, and it's pretty easy to see from here. So what you do is you, something's happened. With my OneNote, it is not responding. Oh, there we go. It's alive again. So factor the expression, write the factors on the left of this elongated L right here. Do you remember doing this?
Oh.
Well, something is really wrong here with my computer today. Do you remember doing this at all? Is this ringing any bells? Ding, ding, ding. No? No one's remembering this? For real. Ouch. Okay. So, this is what you do then. You find out what the factors are of this expression. They're already given here. Then what you do is you write the factors on the left side of this line. Okay? On the bottom, you're writing a number line. Okay? A number line. Now, how did I know to put these values here? Let's back up a little bit. Okay? What you want to do on this number line is you want to write the values that make each of these factors 0. So in this one, if x is positive 3, 3 minus 3 is 0. So that's why I'm going to put 3 down here on this number line. Okay? 3 is going to go on there. Now for this one, x minus 2, the 0 is where x is positive 2. And so positive 2 is going to go on the number line as well. And you want to make sure it's to the left of number 3, so it looks like a real number line. And finally, x equals negative 1 here. That makes this 0. So that's why I have negative 1 down here in this number line. Okay. So why are the zeros significant? Well, I know that, let's say for this one right here, x plus 1, this factor, I know is 0 at x equals negative 1. You see that? So these are really the x values on the number line. I know it's 0. So what happens if x is greater than negative 1? Okay, let's see. If x is greater than negative 1, let's say it's 2, or let's say it's 10. 10 is greater than negative 1, right? That would be over here on the number line somewhere. Is this positive or negative now? Positive. Does that hold true for any value that's greater than negative 1, like 0? Yep, that's positive. What about 2.2? Yeah, that's positive as well. You see that? So those are all positive. So what I do now is on the same line here, I just write, I know that all of these values make this factor positive. So everything greater than negative 1 makes this factor positive. Why am I only concerned with the positive values? Well, again, all I'm trying to find out is this right here. Where is this y value, this function, f of x? Where is it greater than 0? So if I knew that this was negative and this was negative and this was positive in a certain region, I know that now y is positive, right? So all I need to know is the signs, positive or negative for any x value. So that's what we're going for. We're going to try and find out if these are positive and negative and what intervals those are positive and negative. So what about on the left side of negative 1? So if something is, let's say it's negative 10. What's negative 10 plus 1? Well, that's not positive anymore. That's negative 9, right? So it's negative. Let's say it's negative 2. Well, that's going to be a negative value, and so on. So that means you put negative signs in the row to the left of this 0. And just a hint, I mean, just a heads up. This is the way it's going to be most of the time. Negatives on the left, positives on the right. As long as your x value, if this term is positive, then this will always happen. If the x is negative, then it's going to be opposite. But let's just do another one here. So x minus 2, we said that at positive 2, this is 0. So let's put a 0 there above positive 2. You see that? Right above. We'll put that 0 there. And then if x is something like 3, 3 minus 2 is a positive 1. So everything to the right of that x value is positive. So I fill those in. any x value that I would substitute into this particular factor would make the factor negative if this the values were like -1, for example. -1 minus 2 is -3, so it's all negative there. See that? You do the same thing for the other one. 0 there. You just do a quick check, and that's positive, that's negative. All right, you with me so far? All right, so that's part of the sign analysis. We're analyzing each factor. Now what we do is we show what the y value is now. So y. So let's put down here in this kind of lower area, what happens when I have a value that is less than -1? Well, I have a negative value from this factor times a negative value from this factor times a negative from this factor. They're all negative. So what is the product here when I multiply them? Because see, these are all multiplied together. So a negative times a negative times a negative is going to give me what?
Negative.
Negative. So you draw little negative signs in this area right here. What happens at -1? Well, my first factor is 0, right? So 0 times whatever, that's 0. So I'm kind of getting a picture of what my function kind of looks like. The graph is below the x-axis here. Now it's going to cross the x-axis at x equals -1. So positive times negative, what's that going to be?
Negative. I mean positive.
Positive, okay? Positive in there. Then at x equals 2, it's 0 because this one now is 0. See that? Let's restart my computer. Okay, and over here, again, just look at the signs. Positive times a negative is negative. We have positive times 0. At 3, it's 0. And then these are all positives. Okay? So, where is this function, y or f of x? Where is it positive? Well, wherever it's on the intervals, wherever you see positive signs down here. Okay? So f of x is greater than 0 on the intervals. Now let's see. It says greater than, not equal to. So we have to be careful here. Interval notation, let's say round bracket from -1, comma, to +2. And also, where? Where else is y positive? What's the interval here?
3 and infinity.
Round bracket from 3 comma to infinity. So what that means is we don't know the exact values here, but we have a ballpark. We know that it's negative here, so the graph is probably something like this. Negative, see, it's below the x-axis here, and then it hits 0 at -1, and then it goes above the x-axis for a little while, and obviously it's going to come back down somewhere around and hit the axis at 2, and then it's going to dip below the y-axis. I don't know how far it goes, but it comes below, and then it's back up to 3, because it's back up at 0, and then it's above, like this. So it would kind of look something like that, maybe. And what we could do and should do is check our friend Desmos and ask him what that looks like. Okay, so somebody read to me that function. It was y equals what?
X.
So x, here we go, plus 1 times what?
X minus 2.
Minus 2 times x minus 3.
Yep.
Look at this. Here is the graph. Right here. And you see how we've got that looks pretty close actually. See? So we didn't graph that at all, but we have an idea of what this graph kind of looks like. You see, that's pretty close. And we know where it's below the x-axis, we know where it's above the x-axis, we know where it hits the x-axis at those 3 points right there. -1, 2, and 3. Okay? So that's using algebra to do sign analysis to find out where the function is positive and where it's negative. Okay? Questions? So what we don't know is where this line goes up to. We don't know if it goes up here. We don't know if it goes like this. We don't know this yet. We don't know these values yet. Not yet. But these values are going to be at a spot, at a place where the derivatives are what?
0.
So if there's going to be a maximum, we know the derivative will be 0. So we could use that. Now that's the next step. We can use that knowledge to find out how high the graph goes. Okay? But anyways, that's right. It's a good question. We don't know some of that yet. All right, so what I want you to work on today is, I think the assignment is written down here somewhere. Okay, here we go. So page 163 and page 166, you're going to get to practice interval notation and also some sign analysis. So that's review and preview to chapter 4, interval notation and sign analysis. So there's the textbook for the first section, and where is it? And there's the textbook for the second section.